Hello friends, in the previous lecture we have discussed the basic working of the hydroelectric power plant. Now today we are going to discuss the schematic arrangement of the hydroelectric power plant. The hydropower station simply involves conversion of hydraulic energy into electrical energy. So in hydroelectric power plant the potential energy of the water is converted into kinetic energy. Then kinetic energy is used to rotate the blades of the turbine and which is coupled to the alternator which will convert the rotational energy into electrical energy. It is necessary of the proper arrangement overall plant for better working efficiency. The whole arrangement is divided into certain stages for the understanding purpose or for the sake of simplicity. The first structure is called as the hydraulic structure, second is called as the water turbine, and third one is the electrical structure. So this particular thing is called as hydraulic structure, this is your water turbine, and this is your electrical structure. Now what is the hydraulic structure? The hydraulic structure in the hydroelectric power station includes dam. So the most important part of the hydraulic structure is the dam. Then spillways, headwork, surge tank, penstroke. So this is the penstroke over here. Okay, this is the two major parts, that is the first one is the dam, second is the penstroke. Then spillways are also used. The spillways are used to release the excess water over there. An accessory, dam. The first we are going to discuss the dam. Now, a dam is a barrier which stores the water and creates the water head. Dams are built of concrete or stone, masonry, earth or rock fill. So there are different types of dams. The dam may be built because with the help of concrete. It may be built with the help of stones, masonry. The type of arrangement depends upon the condition of the site and which type of dam you are going to construct. That depends on the location, site location. A masonry dam may be built in a narrow situation and the earth dam may be built best suited for the wide valley. Okay, so what is the spillway then? Spillway. There are some times when the river flows exceed the storage capacity of the reservoir. Such a situation arises during heavy rainfall in the areas. In order to discharge the surplus water from the storage reservoir into the river on the downside stream of the dam, spillways are used. So if you have seen that, these are the spillways. Okay, at the dam, just near the gates, you can see such type of structure over there. So when the dam is completely filled, okay, because of the heavy rainfall in that region, at that time the excess water is going to be released to the river through the spillway. Spillways are constructed of the concrete pipe on the top of the dam. Gates are provided between these piles and surplus water is discharged over the chest of the dam by opening these gates. Spillways are constructed of the concrete pipe. Okay, then next one is the headwork. The headwork consists of the divergent structure at the head of the intake. They generally include booms and racks for diverting the floated derbies, slurries for by bypassing the derbies and sediments, and valve for controlling the flow of water to the turbine. And the most important thing is the surge tank that is normally constructed near or here. Okay, so in the surge tank, in this diagram the surge tank is not shown over here. A surge tank is the small reservoir or the tank open at the top in which water level rises or falls to reduce the pressure swings in the conduct. The surge tank is located near the beginning of the conduct. When the turbine is running at a steady load, there are no surges in the flow of water. That is, the quantity of water flowing in the conduct is just sufficient to meet the turbine requirement. However, when the load on the turbine decreases, the governor closes the gates of the turbine, reducing the water supply to the turbine. The excess water at the lower end of the conduct rushes back to the surge tank and increase the water level. Thus, the conduct is prevented from bursting. So basically, the purpose of surge tank is for the safety purpose. It will protect the Conduct means that your penstock over here. So normally the location of the surge tank is over here. So what happen? My water is flowing to the turbine will rotate, the red rotates the alternator that will generate the electricity. So sometimes what happens when the load on the system will reduces, electrical load on the system will reduces, at that time my voltage will be more. So I need to reduce the power generation. For reducing the power generation, I need to slow down the turbine. For slowing down the turbine, what I have to do? I have to reduce the flow of this water. Okay, so for that purpose, a governor system is there. That governor system will continuously take care of the changes in the load or variation in the load. So now, when that governor will closes this valve, so when this valve will close, the water flow is going to be reduces. So what happen in the surge tank which is open at the top, the water level go on increasing. So when the water level will go on increasing, what happen, that water which is excess over here, that is going to be put into the surge tank, and that conduct is going to be prevented from bursting. So this is the main purpose of the surge tank over here. Now what is the penstock? Penstocks are open or closed conduct which may carry water to the turbine. So this is the penstock. This may be open or closed. Normally we are going to use the closed conduct that will carry the water from dam to the turbine blades. They are generally made up of reinforced concrete or steel. Concrete penstocks are suitable for low height. Low height means less than 30 meters, as a generator pressure causes the rapid deterioration of concrete. The steel penstocks can be designed for any height. The thickness of the penstock increases with the height or the working pressure. Okay, so there are commonly used two types of penstock. One is the concrete type and one is the steel type. So concrete type penstocks are suitable for low height, which is less than 30 meter. But if your head is more, then we will prefer the steel type penstock. Various devices such as automatic butterfly valve, air valve, such tanks are provided for the penstock of protection of this penstock. Automatic butterfly. Now, the valve stop. The automatic butterfly valve shuts off the water flow through the penstock promptly if it is rupture. Air valve maintain the air pressure inside the penstock equal to the atmospheric pressure. Now, third thing that we are going to discuss over here is the water turbine. So, water turbines are used to convert the energy of falling water into the mechanical energy. The principal type of water turbines are impulse turbine and reaction turbine. What is the impulse turbine? Impulse turbines are used for high heat. An impulse turbine, the entire pressure of water is converted into the kinetic energy in a nozzle, and velocity of the jet drives the wheel. The example of these turbines is the Pelton wheel turbine. The force of water jet is striking on the buckets on the wheel drive on the buckets on the wheel, and that will drive the turbine. Second one is the reaction turbine. The reaction turbines are used for low heat and medium heats. In reaction turbine, the water enter the runner partly with the pressure energy and partly with the velocity heat. The important types of reaction turbines are Francis turbine and Kaplan turbine. Francis turbines are used for low and medium heat, and the Kaplan turbine is used for low heat and large quantity of water. Then the most second part is the tail race. So tail race is nothing but the path through which the water is pumped out of the hydropower plant after power generation. Okay, so this is the second part. Then this one is the electrical part. The electrical equipment which are used in the hydroelectric power plants includes alternator, transformer, circuit breaker, transmission line, and other switching and protection devices. So hydroelectric generator, the generator which are driven by the hydro turbines are called as the hydroelectric generator. They are run at lower speed, less than 1000 rpm working. In the method of generation, what happens? The water is carries from your dam to the through the penstock to the water turbine. The water turbine will rotate, that will rotate the generator. The generator will convert the rotational energy into electrical energy. That electrical energy is going to be step up over here, then it is transferred at higher voltage through the transmission line to the consumer.